So our next topic is model evaluation. So in this topic we will learn about how to perform model evaluation using Python and accounting for unequal errors caused using Python. So what is model evaluation? In data science, model evaluation refers to the process of assessing how well a machine learning model performs on a given task. This is a critical step to ensure that the model is not only fitting the training data but is also generalizing well to new, unseen data. Model evaluation helps in determining the accuracy, reliability, and effectiveness of the model before it is deployed in real world application. So here are the methods of model evaluation. In machine learning and data science, model evaluation is crucial for understanding how well a model generalizes to unseen data. Several methods are used to evaluate each other to different types of problem, regression, classification, etc. So here are the methods. First is holdout method. The dataset is split into two parts, a training set and a test set. The model is trained on the training set and evaluated on test set. Commonly used in simpler evaluations but can be sensitive to the specific split, which is why it's often paired with other techniques like cross validation. Second, we have cross validation. Cross validation is used to ensure the model's performance is not dependent on a single training test split. Third, we have bootstrap method. The bootstrap technique involves creating multiple datasets by sampling with replacement from the original dataset. Fourth, we have performance matrices. Evolution depends on the type of problem, regression versus classification, and the appropriate matrices for classification. Accuracy, the proportion of correctly predicted instances to total instances. Precision, the proportion of true positive prediction for total predictive positives. Recall, sensitivity, the proportion of true positive prediction to the total actual positives. F1 score, the harmonic mean of precision and recall, balancing both. Now, performing model evaluation in Python typically involves using sklearn, a powerful machine learning library. Below, I will walk you through the steps for evaluating a model in Python using a simple classification task using a dataset to predict whether an email is a spam or not. This example will demonstrate how to split the data, train a model, and evaluate its performance using matrices like accuracy, precision, recall, F1 score, and confusion metrics. Accounting for unequal error cost. In many real world machine learning applications, the cost of different types of error, false positive and false negative, are not equal. This is known as unequal error cost or asymmetric classification cost. For example, in medical diagnosis, a false negative missing a disease might be more costly than a false positive incorrectly diagnosing a disease. In such cases, we can modify our evolution strategy and use cost-sensitive learning or weighted matrices to account for those unequal cost. This can be done using custom cost matrices or by adjusting the model's prediction strategy to prioritize minimizing the more expensive errors. So steps accounting for unequal error cost are: first, load and prepare the data; second, train the model; third, calculate the custom error cost using a cost matrix; fourth, evaluate model performance considering unequal error cost. Now we will look forward to the code. Here we are importing libraries. We will use sklearn for machine learning task, matplotlib and c1 for visualization. And you can see here we have imported numpy as np, pandas as PD and sklearn dot model selection, and here we are importing train test split from sklearn dot learn model, and all the models are imported over here, modules. So here we are going to load and prepare the data. Here we will load dataset, iris dataset in this class. Data is equal to load iris, x equal to pd dot data frame, and y equal to pd dot series. Then we will display the first few rows of the data. After this, we will split the data into training and test set. We will split the data into training 80% and test data into 20%. Splitting data into training and data set is done over here. You can see, and we will train the model now. In this case, we will use logistic regression as the model for simplicity. You can see after logistic regression, we will make predictions. Now we will use the train model to make predictions. As you can see here, it will make prediction on test data. Now we will evaluate the model using matrices, and we will calculate evolution matrices. Then we will print the matrices. You can see print accuracy, print precision, print recall, print F1 score. Then we have confusion matrix. A confusion matrix will help in visualizing the model performance in terms of true positive, false positive, true negatives, and false negatives. We will compute the confusion matrix, and you can see we have plotted the confusion matrix using C1 heap map, and here is the confusion matrix. So this is all for today's video. Thank you for watching.